The hypothesis testing procedures for testing claims about two population parameters are performed in the same way as the hypothesis testing procedures for one population parameter. As previously, we will check the assumptions, set up the hypothesis, and compute the test statistic using a specific formula, and then use the critical value approach or the p-value approach to decide whether to reject or not reject the null hypothesis. Next, we will discuss the nuances of setting up and testing the hypothesis to test the claims about two population parameters. We first introduce a few new terms. We call a pair of samples independent if the observations in one sample do not influence the observations in the other. We call a pair of samples dependent if the observations in one sample somehow influence the observations in the other. We call a pair of samples paired if the observations are paired in a distinct way. Note that paired samples are dependent, but not every dependent samples are paired. Consider the following three different ways to pick a sample of 10 males and a sample of 10 females. It can be done on two different occasions, or it can be done simultaneously by picking male-female couples or rotating between males and females. Which of the samples are independent, dependent, and paired? Ideally, we want to separate the two samples, so the bottom one is the example of independent samples. The top one is the example of dependent samples. Note that dependency doesn't have to be explicit. And the middle one is the example of paired samples. Other common examples of paired samples are the samples obtained for the same subjects before and after some event. We will learn how to test statistical claims that compare a pair of independent parameters of two populations, such as two independent variances, two independent proportions, or two independent means, when population standard deviations are known or not known, but can be assumed equal or can be assumed not equal. We will also learn how to test statistical claims about two paired means. Consider the following examples of statistical claims that involve the parameters about two populations. The average GPA of female students is greater than the average GPA of male students. Can be symbolically written as mu1 greater than mu2. The percentage of baby boomers that support the Democratic Party is less than the percentage of millennials. Can be symbolically written as P1 less than P2. The income variation is not the same among those who graduated from college and those who didn't. Can be symbolically written as variance 1 is not equal variance 2. So far, it is as intuitive as before. However, we are going to rewrite the claims in a different way. Saying that mu1 is greater than mu2 is the same as saying that mu1 minus mu2 is positive. Saying that p1 is less than p2 is the same as saying that p1 minus p2 is negative. By writing it as a difference, we can now take advantage of the fact that the difference of two normal distributions is also normal. Similarly, saying that variance 1 is not equal to variance 2 is the same as saying that variance 1 divided by variance 2 is not equal to 1. By writing it as a ratio, we can now take advantage of the fact that the ratio of two chi-square distributions follows F distribution. Another benefit is that by writing it this way, we can create more interesting statements by replacing 0 and 1 with another number. By changing 0 to 1/2, we obtain a slightly different claim. The average GPA of female students is at least half a point greater than the average GPA of male students. By changing 0 to negative 0.1, we obtain a slightly different claim. The percentage of baby boomers that support the Democratic Party is less than the percentage of millennials by 10% or more. By changing 1 to 2, we obtain a slightly different claim. The income variation is not twice as large among those who graduated from college and those who didn't. This table summarizes the null and alternative hypotheses for which we have developed the testing procedures. A few more terms. A pooled statistic is a statistic computed from two samples as if it was one sample. For pooled proportion, we have the following formula. For example, if the proportion of males in one class is 9 out of 26 and in the other class it is 12 out of 24, then the pooled proportion will be equal to 0.42. For pooled standard deviation, we have the following formula. For example, if sample 1 of size 8 has the sample variance 3.84 and sample 2 of size 16 has the sample variance 6.12, the pooled standard deviation is equal to 2.32. We discussed a few nuances of setting up the hypothesis to test the claims about two population parameters. Next, we're going to test a variety of claims.